Welcome students. In this lecture, we are going to discuss some more examples on class intervals, that is the summarizations that we make. We'll particularly focus on the summarization method, the table that we make. We are not going to discuss the analysis because analysis we have already discussed how we do for the class interval summarized data, and I would suggest you that go to that view that video so that you can have the understanding that how we do it. But over here we are just going to discuss the summarization. So let's take the example for this. We have a table contains the data set, and you have to develop a class interval summarization for the following data set. Now over here we can see that there are a lot of numbers present. It's a big data, not a small one. So we have to be very careful while we are doing the class interval summarization. And that's what we are going to learn in these examples. So the first important thing to note over here is this, that the data set given to us has a data type which is integer. There are no decimal values present. Now this is important thing over here because in later examples we would be seeing the data sets comprising of the data types having decimal values, one decimal place, two decimal place, and a little change occurs in doing the summarization. So be careful and note this observation. So our data set has a data type which is pure integer. It has no decimal values. So it's a simple data set. Uh, how we proceed with the class interval summarization is the method is same, but when the data set size changes, so little bit things change as well, and we are going to discuss those changes particularly. So over here we have developed a little template. This is the data set that we are going to work upon, and the first thing that we need to know is the number of classes or the number of groups that we are going to have in it. The second thing is the class height and then the class width, and then there are some calculations for the class boundary. I'm going to give you the technique over here, because sometimes, many times it happens rather, that while we are working with large data sets, we make some mistakes that we sometimes override the values or sometimes we miss the values. So I'm going to discuss this thing as well, that how can we avoid those problems. So firstly, the total data set size is what? Because we know this thing that in order to find the total number of groups or the classes, we have the formulation that this is equals to log n upon log 2, where capital N, which is in log n, is the data set size. So when we have the data set in the form of a matrix, or in the form of a table, something like this, so it's easy to count the total number of values. And we have basically 1 2 3 4 5 6 7 8 9 10 columns, and 1 2 3 4 5 6 and 6 rows. So this means the total data set size is 6 by 10, that is 60. So we have 60 values over here. It's not a small one, it's a big one, and that means the data set size is quite big over here. So we'll just put log 60 upon log 2. And what is log 60 upon log 2? We do the simple calculation, and the answer that we get is 5.906. So log 60 upon log 2 gives us the answer, which is 5.906, which basically means we have to round it up to the next higher integer value, which is 6. So that means in all we can have 6 classes over here to sufficiently summarize it. So we can have 6 classes over here. Now next comes the class height, and for this purpose we need to know the range and the total number of classes that we have decided upon. So we can just first put the denominator, the range, for the small n, sorry, which is the number of groups or classes, which is 6. And for the range we need to know the difference between the maximum and the minimum value. Now it's a very simple thing to do. You don't need to arrange the data in the ascending order. Just try to understand the trick. Now I start with the first column. In this column, I'm first starting with the maximum number. In this first column, the maximum number that I can get is 80. Right? Now I'll move to the next column and see if I can get a number which is greater than 80. If I get it, then I will basically discard the previous 80 value and put that number as my highest number so far. But in this column, I can see no value which is greater than 80. In the third column, there's a value which is 83. So by this third column, my highest number has become 83, and I can discard 80 as my highest number. But if I move further, I get 89. So that means 89 should be the so far the highest number. In the fourth column, I get a number which is still greater than 89, and that is 95. So I will put 95 as my highest number and discard all the previous numbers that I took. Then in the fifth column, there is no other number which is greater than 95. In the sixth column, there's again no number greater than 95. Then in the sixth column, this is sixth one, right? 1, 2, 3, 4, 5, 6. If there is no number greater than 95, then in the seventh, there is no number greater than 95. In the eighth, we have a number which is 98, greater than 95. So we can discard all the previous greater numbers and take this one as the highest number so far. Then in the next column, is there any number greater than 95? No, I don't see. And so in the last column as well, there is no number greater than 98. Sorry, pardon me, 98. So there are no numbers greater than 98 in the ninth and 10th columns. So that means in order to calculate the range, the maximum number is 98. Sorry, the maximum number is 98, and we can just plug it in over here. And we then need to find the difference between the maximum and minimum number. In the same way, we try to find the minimum number. So we again start with the first column. Our minimum number in the first column is 23. We move to the next column, then we get a number which is 10. In the third column, there is no number less than 10. In the fourth column, there is no number less than 10. In the fifth, sixth, seventh, eighth, ninth, and 10. No numbers less than 10. So that means over here we can put 10 as the minimum number. Let's try to find the difference between the two. 98 minus 10, and then divide it with 6. We get 14.66. So we get a number which is 14.66. Now be careful while we are interpreting it, because now we are going to have examples. The next lectures we are going to have examples in the next videos which will have data set types, not just integers but rather real numbers. So be careful when we are working with the height and the width of the class. When we have the data set as integer type, then we only need to round up this integer part of the data set, okay, to get the class height, and we need to truncate this integer part of the data set to get the class width. Remember this thing. So in this way, this means that our class height would become 15, and similarly the class width will become 14. We don't need to write it separately. It's understood. The class width will become 15. So far we have done enough calculations to start filling our class interval table. So we start with the smallest value, which is 10, and then it means 10 plus 15 makes it equals to 25. That is the lower limit of the second class. 25 plus 15 makes it equals to 40, the lower limit of the third class. 40 plus 15 makes it equals to 55, and likewise 55 plus 15 makes it equals to 70, the lower limit of the fourth class. And 70 plus 15, that is 85, becomes the, in the similar fashion, the lower limit of our sixth and the last class. Then the class width, we need to add 14 to the lower limit. So that means 10 plus 14 makes it equals to 24. Similarly, 25 plus 14 makes it equals to 39. Likewise, 40 plus 14 makes it equals to 54. Similarly, 55 plus 14 makes it equals to 69. 70 plus 14 makes it equals to 84. And 85 plus 14 makes it equals to 99. And so in this way, we finish our first column of the class interval table. Now the second column, the frequency. Now this is very important column when we are working with big data sets. And please try to see the trick which I'm going to use so that I may not end up in confusion and erroneous results. The frequencies, as we already know, are the total number of values in a particular class. So, for example, in the taking the first class 10 to 24, how many values have we got? We'll start with the first column. From 10 to 24, there is no value present. But yep, there is one, the very first cell, the 23. So what we do in order to remind us that we have already taken this as our cell of requirement, we just fill it with a color so that we may not be counting it again and again. So 23, right? 10 to 24. Similarly, we move on to the second column. We get a value 10, definitely part of this interval, and we fill this with a similar color again. Then 10 to 24, there is one other value in the third column, which is 17. Then 10 to 24, none in the fourth column. 10 to 24, fifth column, no value. 10 to 24, sixth column, no value. 10 to 24, seventh column, no value. 10 to 24, eighth column, no value. 10 to 24, ninth column, one value is over here, which is 15. Let's fill it up. And 10 to 24, 10th column, no value. Just make a quick recheck so that we may not be losing or missing any values. If we will be losing, then we would see at the end of the table and we can adjust it. So no issues, but rather just confirm this thing so that we may have no issues at the end as well. So we can see there are four values present in this interval, and we mark four with a similar color and bold so that it could be recognized. Then 25 to 39. So 25 to 39, we have got one value over here, and in a similar way we mark it with a different color. You can just take any color. I'm picking the red one. Then 25 to 39, any other cell? No. 25 to 39, 25 to 39, 25 to 39, fourth, fifth column, no value. 25 to 39, we have got one value in the sixth column, and likewise 25 to 39, sixth column, no value. 25 to 39, seventh column, no value. Sorry, eighth column, no value. 25 to 39, 25 to 39, no value in the ninth column, and yep, the 10th column we have got 36 and no other value. Just make a quick recheck of the things. 25 to 39, no values, no values. In yep, there is one value which we missed, so it was 32. So be very careful with these things because these things happens in huge data sets, big data sets. And 25 to 39, no value over here, no value over here, no value in the eighth column, and in the ninth column, in the 10th column, no value. So how many values have we got in this interval? 1, 2, 3, 4. So we've got four values over here. We move on to the third class, 40 to 54. So 40 to 54, we have got one value over here, and there's one as well which I can see which we missed. So 52 as well is part of this class. All right, 40 to 54 is our interval. 40 to 54. We move on to the third class, no value in this interval. And in the fourth column, third column, pardon me. In the fourth column, we have got one value, 54. 30 to 54, we have got values in the fifth column as well. 30 to 54, sixth column, no value. Seventh column, we have got one value. And likewise, eighth column, there is no value. Ninth column, there is no value. And 10th column, 30 to 54, where there is one value which is 43. Let's quick recheck of the things so we may not be missing other values. Nope. So it seems that all the values have been taken care of. No, there is one value 48 in this column which was missed, and 30 to 54, 30 to 54 seems that we have filled up all the spaces for this interval. So 1, 2, 3, 4, 5, 6, 7. So we have got 7 over here. Then we have 55 to 69. So 55 to 69, there is one cell present in the first column, and this one goes like this. 55 to 69 is 60. 55 to 69, then we have got 67. 55 to 69, we have got 64. 55 to 69, we have got 57, and as well 64 and 69 as well in this column. So 55 to 69, we have got 65, and then we have got no other value in this column. So 55 to 69, we have got 63. 55 to 69, we have got 62. 55 to 69, we have got 55 itself. 55 to 69, there is no other value, just there is one. 61, and I can see others as well. There is 67 as well. So hopefully we have not missed any other value for this interval. So what is the count then? This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have got 12 values for this column. Then 70 to 84. So 70 to 84 is 80 over here. 70 to 84, there's 77. And then we have 70 to 84, 78 and 71. Both are coming over here. Then 70 to 84, we have got 79 and 80. Then we have got 70 to 84, there is 83 as well. Then 70 to 84, there is 75. 70 to 84, there is 76 and 82. Then 70 to 84, we have got 78 as well as 84. So just fill it up. 70 to 84, we have got 74. We are just filling them with colors so that they may not confuse us at the end that whether we have taken them or not. 70 to 84, we have got 80. You can use shades as well. It's just a matter of recalling easily the things. So 70 to 84, and likewise 70 over here, and 80 over here. 70 to 84, we have got 82, and then 74 and 81 both would be coming, and then 76, and then 79. So many values for this interval. And what the frequency comes out to be, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So you've got 24 frequency for this class interval. And then comes the last one, which is 85 to 89. So all the remaining one are for will go in this interval. So just fill it up with any color which you like. So 85 to 89, sorry 99, and this one 85 to 99, then this one 92 will also be part of this class, and then 85, 98 both will be part of this class. 90 will also be part of this class, and in the end 85 will also be part of this class. It looks pretty much good. All the bricks have been filled, which means we haven't lost or missed any value. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 is the count. And let's just see that whether we're on the right track. Let's add all these frequencies and see what comes out. 4 plus 4 plus 7 plus 12 plus 24 and then plus 8. And it comes out to be 59. So we are missing something. And let's see where we are missing. Let's see. So 10 to 24, which was with the yellow color. So when you mark them with the colors, then it is easier to recheck the things as well. So 10 to 24, we had 23 and 10 and then 17. So it's 1, 2, 3, 4. 4 was the frequency. 25 to 39, which was with red. So 1, 2, 3, 4. 40 to 54, which was with blue. So it was 1, 2, 3, 4, 5, 6, 7, 7. And then we have 55 to 69, which was with green. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's 13. So we missed the count over here, which was 13. So see, the colors help us to troubleshoot the things as well. And when we add them all, we get the number, which is the total number of frequencies or total data set values, which is 60. Next comes the column of relative frequency, also called the probability for the class to appear at the output, a value from this class to appear at the output. So it is 4 by 60, sorry, 4 by 60 for the first class, and again 4 by 60 for the second class, then 7 by 60 for the third class, then 13 by 60, and similarly 24 by 60, and lastly it is 8 by 60. And when we add them all, it's 1, indicating that they are probability values. It's the sum of the probability of all the mutually exclusive events is always equals to 1, and this makes perfect sense over here. Cumulative frequency is our fourth column. We are going to sum up the frequencies with the frequencies of the previous classes. So for the first case it is 4, then 4 plus 4 is 8, then 7. The frequency of the third class is going to add up with the total frequencies of the preceding classes, which is 8 so far. So 7 plus 8 is 15. Then 13 plus 15 is 28. Then 28 plus 24. And what's the sum of it? So it's 28 plus 24. And this is 52. And lastly, 52 plus 8 is 60. Confirming that our results are so far very good. Now the class boundary, as we already discussed this thing, that class boundary is used to make the data continuous. It is done in two steps. First, we need the jamming factor to bond the things we need, like when we basically integrate the things together, we need some bonding factor, something to jam, like like a clip or a pen to jam the papers, a tape to jam the things, a glue to jam the pieces of wood. The jamming factor is determined by finding the difference between the lower limit of class 2 minus the upper limit of class 1. So 25 minus 24 upon 2 makes it 0.5, and that's it. We are going to basically subtract 0.5 from the lower limit of every class and add 0.5 to the upper limit of every class. And that's how the game goes by. So 10 minus 0.5 is 9.5, and 24 plus zero point 0.5 is 24.5. Likewise, 25 minus zero point 0.5 is 24.5, and similarly 39 plus zero point 0.5 is 39.5. For the third class, 40 minus zero point 0.5 is 39.5, and similarly 54 plus zero point 0.5 is 54.5. Then we have 55 minus zero point 0.5 is 54.5. Then we have 69 plus zero point 0.5 is 69.5. Then we have 70 minus zero point 0.5 is 69.5. And then we have 84 plus zero point 0.5 is 84.5. And for the last class, 85 minus zero point 0.5 is 84.5. And then we have 99 plus zero point 0.5 is 99.5. And so we can see that this is the class boundary, because the value or the number at which a class ends is the same at which the next class is beginning. So this makes perfect sense that the data is continuous now. Now the class mark, which is the single representative of the class or the middle value of a class, this can be found either by summing the two values of the class interval and dividing by 2, or the two values of the class boundary and dividing by 2. So it's 10 plus 24 divided by 2, and this is basically 17. So the class mark for the first class is 17. Likewise, 25 and 39 are the limits for the second class. So 25 plus 39 and divided by 2 makes it equals to 32, which is the class mark for the second class. Then for the third class, it's 40 and 54. So 40 plus 54 divided by 2, and this is 47, the class mark for the third class. And then 55 and 69. So 55 plus 69 divided by 2, that is 62, and 70 and 84 for the fourth class. So 70 plus 84 divided by 2, which is 77, and the end class is 85 and 99. So 85 plus 99 divided by 2, it is 92. Yep. So that's it. Our table is completed. One thing I want you to observe again is this, that remember this rule which is going to be experienced in the later examples. When we have the data set of pure integer type, the class boundary comes out to be a decimal value with one place decimal value. Okay, later on we will see then that when we have the data set as decimal values and the decimal values are precise to one decimal place, the class boundary will come out to be precise to two decimal spaces, and so far so on this rule goes by. So again repeating, since our data set was without any decimal values, it was pure integer, therefore the class boundary came out to be precise at one place decimal value, right? So that's how we basically summarize this data in class interval summarization by way, and hopefully you have understood this idea. In the later videos we will see some more examples of the summarizations using the class interval method. If you have any queries, any confusions, you can write down in the comments and I'll come back to you. Thank you very much.